How do you see your friends, your favorite book, or the beautiful colors of a rainbow? It all comes down to something amazing and incredibly fast: light. Today, we're going on a journey to uncover the secrets of light and vision. So, let's get started and illuminate our minds. To understand how we see, we first need to understand what light is. Think of light as tiny, superfast particles that travel in straight lines. We call these lines light rays. The biggest and most important source of light for our planet is, you guessed it, the sun. The sun sends out a huge amount of light, which travels all the way to Earth and brightens up our day. But the sun isn't our only source of light. When it gets dark, we switch on light bulbs. These bulbs also produce their own light, allowing us to see inside our homes. Things that create their own light, like the sun, stars, and light bulbs, are called luminous objects. They are the primary sources of all the light we experience. Now, here's a question. What about things that don't make their own light, like a chair, a book, or even the moon? How do we see them? These are called non-luminous objects, and the secret to seeing them is something called reflection. When light from a luminous source, like a lamp, hits an object, like this apple, the light bounces off it. This bouncing of light is what we call reflection. Imagine throwing a tennis ball against a wall. The ball hits the wall and bounces back. Right, light rays do something very similar. They travel from the light source, hit the surface of an object, and then bounce off in different directions. That's the magic moment. Our ability to see objects that don't produce their own light is all thanks to reflection. Without it, the world would be a very dark place, with only light sources visible. Let's explore reflection a bit more with something we use every day: a mirror. Mirrors are special because their surfaces are very, very smooth. When light rays hit a mirror, they don't just bounce off randomly. They reflect in a very neat and organized way. This is called specular reflection. Think about our tennis ball analogy again. If you throw the ball straight at a flat wall, it comes straight back to you. Light behaves in exactly the same way when it hits a mirror. The angle at which the light ray hits the mirror is called the angle of incidence, and the angle at which it bounces off is called the angle of reflection. For a smooth mirror, these two angles are always equal. This predictable behavior is what allows mirrors to form such clear images. So, how does a mirror create an image of you? When you stand in front of a mirror, light from a source in the room hits your face. That light then reflects off your face in all directions. Some of these reflected light rays travel towards the mirror. When they hit the mirror, they reflect off its smooth surface. According to that rule we just learned, the angle of incidence equals the angle of reflection. These reflected rays then travel to your eyes. Now, here's where your brain does something clever. Your brain isn't aware that the light rays have bounced off a mirror. Your brain creates a virtual image at the location where these lines seem to meet. Tests the reflection you see. It looks like there's another you standing behind the glass, but it's really just a trick of the light and your brain working together. The image is called virtual because the light rays don't actually come from behind the mirror, they only appear to tits, like a sophisticated biological camera that captures all the reflected light and turns it into the images we see. Let's see how it works. When light rays, whether they come directly from a source or are reflected off an object, reach your eye, they first pass through a clear outer layer called the cornea. The cornea helps to bend the light. Behind the cornea is the iris, which is the colored part of your eye. In the center of the iris is a small black hole called the pupil. The iris controls how much light enters the eye by making the pupil bigger in dim light and smaller in bright light. After passing through the pupil, the light hits the lens. The lens of your eye is amazing. It can change its shape to focus the light rays precisely onto the back of your eye. This back part is called the retina. The retina is covered with millions of tiny light-sensitive cells called photoreceptors. There are two main types: rods, which help us see in low light, and cones, which are responsible for color vision. When light hits these cells, it triggers a chemical reaction that creates tiny electrical signals. Finally, your brain receives these signals and processes them, instantly interpreting them as a picture of the world. It pieces together all the information about color, shape, and movement to form the final image that you perceive. It's an incredibly complex process that happens in a fraction of a second, all without you even thinking about it. So, let's quickly recap our journey. We started with luminous objects like the sun and light bulbs that create their own light. We learned that we see non-luminous objects because light reflects, or bounces, off them. And finally, we discovered how light enters our eyes, gets focused onto our retina, and is then converted into electrical signals that our brain interprets as vision. From a distant star to the screen you're watching right now, everything you see is part of this incredible dance of light. The world is full of wonders, and understanding the science behind them makes it even more magical. I hope you enjoyed this exploration into the world of light and sight. If you found this video helpful and want to learn more about the amazing science that surrounds us, please hit that like button and subscribe to our channel. Don't forget to turn on notifications so you won't miss our next adventure. Until next time, keep looking and keep being curious.